In previous videos, we talked about basic project setup and window customization. In this video, we will start writing some Rust code with Tauri commands. This is Tauri's process model. You can read more details in the documentation. This figure illustrates a high-level design of the process model and inter-process communication. A Tauri app can have multiple windows. Each of them is a web view process. The windows may want to communicate with each other and share some common resources, such as a database connection. There is a core process used to create and orchestrate application windows and other components like notification and menus. All inter-process communication is also routed through the core process. In Tauri, there are two ways for inter-process communication: command and event. These diagrams show how command and event work. Commands are written as Rust functions and can be invoked with JavaScript codes, and the returned response from Rust command function will also be received by JavaScript. You can understand it as a language binding, allowing JavaScript code to call Rust functions. Event works differently. They are fire and forget one-way IPC messages. Unlike commands, events can be emitted from both frontend and Tauri core. We will focus on command in this video and save event for another, so the video doesn't get too long. Tauri provides many built-in commands in JavaScript APIs, allowing the program to perform operations that are normally not possible using a browser, such as file system APIs. We will not go over them here as it's pretty straightforward. Just like a JavaScript library, import the function and call it. No Rust code is required. However, there are scenarios where the built-in commands cannot satisfy your needs. For example, Tauri's clipboard API only supports text, read, and write. What if your app needs support for image? Or if you need to run some high-performance computation code with Rust that JavaScript is not capable of? In these scenarios, you can create your own commands in Rust, and it's very simple. In Rust, define a function just like any regular Rust function, and attach a Tauri command decorator on it. Then register the command handler function in Tauri's builder. In JavaScript, you can invoke the Rust function with its function name. This is the simplest example, and it could get more complicated. In the documentation, the guide, calling Rust from the front end, already did a pretty good job at explaining how to use commands, and I will go into a little bit more details. Here, I've prepared a Tauri app with all kinds of commands. Let's start with the grid command, which comes with Tauri starter code as an example. So all commands has to be decorated with the Tauri command decorator, and the command handler functions must be added to the invoke handler generate handler function in Tauri builder. Let's look at the grid command. On the JavaScript side, I defined a variable called grid name. It's binded to an input box, and whenever I type, the grid name is updated. And whenever grid name updates, it will invoke the grid command with the first name as a parameter. Then grid command handler will receive the first name. It will do some string interpolation and return the string. And notice that the first name variable here is in snake case, and on the JavaScript side, it's in camel case. And this is the convention of Rust and JavaScript. And you don't need to worry about it because Tauri handles the translation for you. Just make sure on the JavaScript side, you don't use snake case. Just use camel case. Okay? So when the interpolated string is returned, the response has a type of unknown because the command handler is written in Rust. So what I like to do is to use Zod schema to parse the response into string. And if it's not string, we will get an error. Then the response will be displayed. So let's try. If I type my name, you can see that the interpolated string is updated in real time. Let's go to the second command. This custom payload command is no different from the grid command, except that the grid command takes in a string and returns a string, while the custom payload command takes in a struct and returns a struct. In JavaScript, instead of sending the first name directly, we wrap it inside the payload, which is the payload parameter in custom payload. The interpolated string will be attached to payload.name and then returned. JavaScript will return this unknown type and use the predefined Zod schema to parse it into an object. Then the object is displayed after JSON stringify. So when I type my name, you can see this payload returned from custom payload in JSON format. You may notice that there is this derive, deserialize, and serialize. What do they do? In the documentation, we can see that Tauri commands use JSON RPC like protocol under the hood to serialize requests and responses. And all arguments and return data must be serializable to JSON. Let's first remove deserialize and see what happens. We get an error saying the trait bound deserialize is not satisfied. And this is because we receive data from JavaScript and the data is a struct. Without making the struct deserializable, we cannot map the data received into the struct. Let's prove it by removing the input and return some random value, and the error is gone. Next, let's remove serialize and see what happens. Again, we get an error saying the trait bound serialize is not satisfied. And this is because we're returning a struct. To return a struct, JavaScript doesn't know how to interpret a struct, so the data has to be serializable. This is similar to web APIs, where data is usually serialized into JSON during transfer and deserialized into JavaScript objects. We can prove this by removing the return value, and the error is gone. So the takeaway here is to derive deserialize if you want to take in a struct and derive serialize if you want to return a struct. Next, let's look at async commands. There's really nothing to talk about this because an async command is just like any regular command. Here, we're sending a request to this URL to get our public IP. We await for the response, then transform the response into hash map and return it. Because we used await, this has to be an async function. But other than that, it's the same as other commands. We also need to put it into the generate handler function. Here is the result. The hash map is serializable and we can display it in JavaScript. Next, window label. If we ask for Tauri window in the command handler, we can use Windows APIs. For example, here we get the label and return it. We can also call emit to emit events to the window, or I can set the properties of the window. For example, I can set the decoration to false or close the window. Here, the window label returned is main. And finally, command with state, the most important topic for this video. It's also very useful if you want to build plugins. Plugins are generally more complex and usually require state management across different commands. And it's the same for commands. Sometimes we need some state management. So here, let's start with the simpler command. We define the counter struct as a state, and it's passed into the command handler like this. But in order for Tauri to give you the count state, you have to initialize the state struct in the main function and pass it to the manage function. What does manage do? Let's look at this documentation. If a value of t is managed by Tauri, adding state t to the list of commands in a command handler instructs Tauri to retrieve the managed value. This means if you let Tauri manage the structs for you, then in the command you can get the state. Here, counter has a single field of type i32 int, and is initialized with the value of 0. We're simply returning the first value of the counter state, which will be always 0. And that's not useful. What if I want to increment the value every time the command is called? So let's call plus equals 1 on this value. But we get an error. Trait deref mute is required. This means the counter state doesn't satisfy the deref mute trait. And what does that mean? Let's first comment this out and look at the solution. Here is the working version. So instead of using i32 as a field type, we now wrap i32 with a mutex. And to increment the value, we do this. It looks much more complicated than this, and I will explain it. Let's first look at why mutex work. So the state takes in a generic type t, which is counter mute, and it should satisfy send and sync. That means the field count in counter mute should satisfy send and sync traits. Send and sync traits are used for multi-threading to guarantee thread safety. If we look at the source code of mutex, we can see that send and sync traits are indeed implemented by mutex. So the state will work. Then, what does this long command do? Let's do it step by step. Let x equals count state.count, so we can get the mutex. It has the type of mutex i32. Then we log the mutex. The type is results mutex guard. So let's get rid of the result with unwrap. We get mutex guard. But what is mutex guard? Let's look at the error here. The error is dereference mute is not satisfied. And if we look at the source code of mutex guard, let's search for deref mute, and we can see that mutex guard implements deref mute. That means we can use a start to dereference the mutex guard, and we can get the i32. And it's mutable. So that's why we can increment a value like this. Just remember, if you want the state to be mutable, wrap it with a mutex. Finally, instead of returning the count value like this, we try another method of inter-process communication in Tauri, which is event. With app handle, we can emit this event to all windows with this payload. And in JavaScript, we need to listen for this event. When we get the event, we assign the value to data, and it will be displayed in JSON format. This button is used to invoke this command. every time I click this button, it will invoke this command, and the incremented value will be emitted to all windows, then updated on the UI. So let's click on it, and we get 1. Let's keep adding. Even if we refresh and click on it, it continues, because the data is maintained in Rust instead of on the JavaScript side. That's all for this video. Hope you find it useful, and stay tuned.